In this last video for lesson 4.6, we're going to be working through exercises 4 through 6 on page 121 in our student journal. In these three problems, we have to describe the similarity transformation that maps each pre-image to the image. Looking at all three of these problems, I can tell that a dilation is going to have to occur because there is a size change. So what I'm going to do first is figure out what kind of dilation has to happen to get them to be the same size. And so what I did in each of these three problems is I started by taking my pre-image and I listed the x and y coordinates, because I'm going to have to perform a dilation, and to do that we know we're going to be multiplying those x and y coordinates by the scale factor. I first need to figure out what is that scale factor going to be. So in number 4, my pre-image is triangle LMN. I have to dilate it so it becomes the same size as L prime, M prime, N prime. So to figure out what the scale factor needs to be, I'm going to pick one of the lengths on my pre-image. I'll pick NM. The length from M to N is 2. After the dilation, that corresponding side, M prime, N prime, is 1. So I need to think about what scale factor would take me from a length of 2 to a length of 1. Well, 2 is getting cut in half, or being multiplied by 1/2, right? 2 times 1/2 is 1. So my scale factor that I need to multiply by is 1/2. So I'm going to take my x and y coordinates of my pre-image and multiply them all by 1/2 to get my new image. So 6 times 1/2 is 3. 6 times 1/2 is 3. 0 times 1/2 is 0. And 6 times 1/2 is 3. 0 times 1/2 is 0. And 4 times 1/2 is 2. So I'm going to plot these three new ordered pairs on my graph. L prime is at 3, 3. N prime is at 0, 3. And M prime is at 0, 2. And so I'm going to go ahead and list that transformation that I just did. My first step in my similarity transformation is to do a dilation with scale factor 1/2. Right. Now I can tell I'm not done, because in order to be done with my similarity transformation, my figure has to map on top of my final image. And so I can tell I'm going to have to slide this triangle over so that it would map onto this final image. So I need to do a translation. I need to get this L prime to map onto the final L prime. To do that, I would have to translate it 1, 2, 3, 4 units to the right and 1 unit down. And if I do that with the whole figure, I have mapped this triangle onto my final image. So to finish off my similarity transformation, I just need to describe that translation. So after the dilation, we need to do a translation. 4 units right and 1 unit down. This list here is my final answer. Let's move on to number 5. In number 5, I went ahead already and listed the ordered pairs of my pre-image. I can tell that I'm going to have to do a dilation to make it larger. So I'm going to pick a length on my pre-image. I'll pick the length AB that has a length of, that has a length of 2. Its corresponding side on the image is A prime, B prime. that length is 4. So in order to change the size, to go from a length of 2 to 4, my scale factor needs to be 2, because 2 times 2 will get me 4. So I'm just going to make a note to myself that the scale factor is 2. And so to get my new ordered pairs, I need to multiply all of these x and y coordinates by 2. When I do this, let's see, -3 times 2 gets me -6. 3 times 2 is 6. -3 times 2 is -6. 1 times 2 is 2. -1 times 2 is -2. And 1 times 2 is 2. I'm going to go ahead and graph these 3 points on my coordinate plane. And so I'm going to go ahead and list that first step. Kind of running out of room. So my first step in my similarity transformation was a dilation with my scale factor k being equal to 2. Now I can tell to map this blue triangle onto my final image, a flip or a reflection will have to occur. It's going to have to flip horizontally, so I'm looking for a vertical line of reflection. And just by looking at the graph, I can tell that the y-axis is in the center of these two triangles, right? C prime is 2 to the left here, and this C prime is 2 to the right. This B prime is 6 to the left, and this B prime is 6 to the right. So I can tell if I reflect this triangle across the y-axis, it will map on top of my final image. And so the final transformation that we need to do is a reflection across the y-axis. And in our very last problem, number 6, I listed the ordered pairs of my pre-image, and I need to dilate it to make it smaller to match my image. So I'm going to pick a length on my pre-image. I'll pick the length SR. This has a length of 3. Its corresponding side, S prime R prime, has a length of 1. So my scale factor in this dilation, to go from 3 to 1, I have to multiply 3 by 1/3. 3 times 1/3 is 1. So my scale factor in this dilation is 1/3. I need to multiply all of my ordered pairs by 1/3 to get my new ordered pairs. Okay. Three times 1/3 is 1. 6 times 1/3 is 2. 3 times 1/3 is 1. 3 times 1/3 is 1. 0 times 1/3 is 0. 0 times 1/3 is 0. And 3 times 1/3 is 1. I'm going to graph this polygon on the coordinate plane. I already have Q prime labeled there. So here is my new polygon, and I can tell that to map it onto my final image, I'm going to have to do a rotation Now, it's always a good idea, even if you have an idea how many degrees you're going to have to rotate it, to just double check using your patty paper. So I'm going to take my patty paper. I have my plus sign with my arrow pointing up. And I'm just going to check by tracing my points here on that blue polygon. I'm going to try rotating this to get it to map onto the final image. So if I rotate it counterclockwise, I've gone 90 degrees, and I can see that these points are now mapped onto the final ordered pair, the final points of my image. And so the next step in my similarity transformation would be to do a rotation of 90 degrees. So let's list that similarity transformation. We first did a dilation with scale factor of 1/3. And then we needed to rotate that image 90 degrees to get the final image.